Hi everyone, and welcome back to another video of IGCSE Math Preparation Series. My name is Irfan, and today we're gonna talk about fractions. So the first thing first, what is a fraction? If you have a single unit and if you divide it into equal parts or equal portions, so you got a fraction for yourself, meaning which if you divide a single unit into 5 portions, and if you take 2 of those portions, you got 2/5 or 2/5. And if you divide it into 10 and take 3 portions, you get 3/10. And if you divide it in half, you get 1/2, right? That's basically a fraction. And we have 3 types of fraction which we need to know how to work with them. The first one is called a proper fraction. Now, what is a proper fraction? Well, if you take a look at any of these fractions, we have a fraction line, right? And 2 numbers, one at the top, one at the bottom. The top one, we call it a numerator, right? This is a numerator, and the bottom one is called denominator. So if the numerator happens to be less than the denominator, then we have a proper fraction. For example, 2/3, 7/9, or 1/10, right? These are examples of proper fractions in which the numerator is always less than the denominator. However, in some cases, we come across fractions where the numerator is larger than denominator, like 12/5 or 7/4, right? Or 3/2. So these type of fractions called improper fraction, right? And another type, the last type, would be the mixed fraction. And what it looks like, it has a whole number and a proper fraction, like 2 and 3/5. So there are 2 ways you can read these, guys. Either you say 2 and 3/5, so 2 and 3/5, or you say 2 and 3/5. Both is correct and both is practical. Of course, if the numbers are too large on the numerator, both numerator and denominators, it would be easier for you to use the word over, and you read it this way. But both is correct. Now, the cool part is that the mixed fraction can be converted to an improper fraction and vice versa. So if you have an improper fraction, you can convert it to mixed. It's just a matter of a simple division. You can perform long division or short division. Let me take 12/5, for example. We want to do it without using a calculator. So 12 divided by 5. How many 5s go into 12? Yeah, the maximum would be 2. We have 10. You subtract it, you get 2. So this is my remainder. This 2 is the whole number that I was looking for. So 12/5 is equal to 2. And these 2, the remainder, goes in the numerator or goes on top. And here, 5. 2 and 2/5. So you can do the same thing for 7. 7 divided by 4, you get 3. 7/4 is equal to 1, and 3, the remainder goes on top, and the 4 goes here, right? So you have to perform the division. However, how do you convert mixed fraction to improper? Well, let's take a look at this guy right here. 2 3/5, which is equal to, so basically what you need to do is to multiply 2 to 5, right? And then add it to 3. So this is multiplication, this is addition. And what do you get? 2 times 10, 2 times 5, 10, plus 3, 13. And you keep the same denominator as 5, and that's the final answer. So it's a very simple and straightforward procedure. Let me give you another example. How do you convert 5 over 5 and 3/4? So 5 times 4, then the result is added to 3, which gives us 23 over 4. As simple as that. So you should know how to go this way and how to go this way, from improper to mix. The next topic would be decimals. Let's talk about decimals, because fractions and decimals, they come together, and you should know how to convert a fraction to decimal and vice versa. So a decimal which looks something like this, I'm sure from your lower secondary you still remember this table, the values of each digit in the specific position before and after the decimal point. So let's say this is my decimal point. On the left we have the unit, the units. Here we have the tens, and here we have the hundreds. Here we have 1 over, basically the tenth, right? The tenth, this one, the hundreds, and here the thousands. So if you have something like 3, sorry, the point is here, 3.213 or 0.1, I put another 0, make it more interesting. So we talk about this when I introduce you to significant figures, right? I said which digit has the highest figure or highest value. So here the digit 3 has 3 values, right? The value is 3 because it's located on units. The 2 here is actually 2/10. So if you want to write this in a fraction form, the 3 is 3, and you add 2/10, and then you add 100, and then you add 3,000, right? And then you get the answer basically in a form of a fraction. However, these 3, the easiest way, if you want to do it in one shot, is nothing but 213 over 1,000, isn't it? Right? Because you can add zeros here to the top and bottom. I add 2 zeros here and 2 zeros here. I add 1 0 here, another zeros here. So if you add all the numerators, what do you get? 210 and 3, that's 213. And here everything is 1,000. So the answer would be 213 over 1,000. And this 3 goes in front. So this is a mix. This is a mixed fraction, right? That's our answer right there. For the second one, this is 25 over 1,000, right? And how did we get this? Well, this is 0, so you can skip that. This is 2 over 100 or 200ths plus 5 over 1,000, and the result is 25,000. Sorry, I missed a 0 here. And that's the answer. You can simplify this further. And basically, this is something that you should do, because in many questions, they ask you write the fraction or write your answer in the simplest form, or there is another way of saying this, lowest terms. So be familiar with both phrases. And what it means is that this fraction can be simplified further. You can divide everything by 25. However, it's not necessary. They didn't ask us to write it in simplest form, so you don't need. Maybe I can give you example of simplest form here. Take a look at this fraction: 1 over 2, 2 over 4, and 4 over 8. Well, at first glance, they might be different numbers, different fractions, but as a matter of fact, they're all equal to each other. How is that so? Maybe I can show you a graphical presentation by using 3 squares. That's very common. Okay, and then the first one, let's say this is the single unit that I was talking about earlier. And if you want to get half, you divide it into 2 equal portions, right? And then you shade one of them, and that's the half. That's the half, or 1 over 2. For the second one, I need to divide it into 4 equal portions and then shade 2 of them. And I get this, which you can see the region which is shaded is the same in terms of area. It's the same as the first graph, right, of the first figure. And the third one, I have to divide it into 8 equal portions. And if I shade 4 of which, you see that it's the same region, same area as the other 2. So basically, these are all equal to each other, right? So what's really happening is that, for example, 4 over 8, because you can't always draw to prove a point that they're all equal, right? We have to use algebra. So if you look at 4 over 8, what is the HCF of 4 and 8? Do you remember when I was teaching you HCF and LCM? One of the application of HCF is simplifying a fraction. So you find the HCF of 4 and 8, or basically the largest number that 4 and 8 can be divided into, and you get the simplest form. You divide it by that number and you get the simplest form. So the HCF of 4 and 8 is 4. And if I divide both top and bottom by 4, I get basically 1 over 2. And same thing here. What is the HCF of 2 and 4? It's 2, right? The largest number that the top and bottom can be divided into. And if I do that, again, I get half, 2, right? Which is the same as, so the simplest version or the simplest form of these two fractions is half. Same thing as 16 over 32. This is still half, or 50 over 100. This is still half, right? So you get the picture where we're going with this. So be careful, the simplest form or lowest term, usually they ask you to leave your answer in that format. So having said that, we get to working with basically fractions and decimals. So I already talked about decimals here, how to convert a decimal to a fraction, but I didn't give you an example of how to convert a fraction to decimal. So maybe we can do a couple of examples as well, and then we get to the arithmetic operation of fractions. So how do you convert this to a decimal? It's actually quite easy, because if you remember the table on previous slide, so you know the value of 6 already, 6 and 3/10. 6 is before the decimal point, and 3 over 10 or 3/10 is basically 0.3, right? Because this is the position of tens, this is the position of hundreds, and this is the position of thousands, and we don't have any of those, so no need to write them. And here we have 4, so this is 365 thousands, and we have the 300, we have the 60, and we have the 5,000s there. And as simple as that. So this is, and you should know how to do it vice versa as well. Let me give you a quick questions, and I want you to do it without a calculator in your mind. 16.0 minus 9.2 minus 5 point, okay, 36. So you find the answer in decimal and then convert it to a fraction. So try to do it in your mind. All right, let's continue with arithmetic operations on fractions. And by that, I mean addition, subtraction, multiplications, and division. Let's start with addition and subtractions. So the idea is, if you want to add two fractions together or subtract them from each other, you need to have the same denominator. So, for example, 2 over 8 minus 1 over 8, if this is the case, you just go ahead and write the denominator, which is 8, and then subtract the numerators, and the answer would be 1 over 8, right? But that's not always the case. We're not always lucky, meaning which the denominators might be different. Then what should we do in that case? Take a look at this example. 2 over 5 minus 1 over 3. Well, you need to make the denominators the same. There are a few ways you can do this. So you can use equivalent fractions, the one that I mentioned. We touched that a little bit on previous videos. So if you want to make the equivalent fraction of 2 over 5 in such a way that you end up with the same denominator as 1 over 3, after we manipulate that as well, you just multiply the top and bottom by 3, right, which is the denominator of this fraction. And then for the second fraction, you multiply that by 5, which is the denominator of the first fraction, right? So you should do that to top and bottom. So in that case, we are forming the equivalent fractions. It means we haven't done any change to the original fraction, to its value. So we're gonna get 6 over 15 for the first one, and 5 over 15 for the second one, and then you're good to go, because now the denominators are same. You just write that down and then subtract the numerators, which give us 1 over 15. Now there is another way you can solve these type of fractions. So whichever suits you, you can practice that method. Let me give you another example, like 2 over 3 plus 1 over 4. So if you recall, I told you the LCM help us in addition of or subtraction of fractions. So you just draw one fraction line here, and what you need to do is to find the LCM of 4 and 3 and put it here at the bottom, right, as your new denominator. So what is the LCM of 4 and 3? Well, 3 is a prime number. 4 can be rewritten as 2 times 2, and the LCM would be 2 to the power of 2 times 3. There is nothing common between these two numbers, or 4 times 3, it's the same thing, right? So the final answer would be 12. So you can write 12, and then you're going to divide 12 by this number, and then multiply that by the numerator and put it here. We get 4 times 2, 8. then the middle sign, which is plus, then do the same thing here, 12 divided by 4 times the numerator, which is 1. So 12 divided by 4 is 3 times 1 is 3, and the answer would be 11/12, right? This method is useful when we're dealing with big fractions, especially big fractions, especially if the denominators, they have some common factors. They're sharing some common factors, such as 12 and maybe 32. And let's say this is 5 and this is 15. So it's quite difficult to multiply this top and bottom by 32, especially if you don't want to use a calculator, and multiply the second fraction by 12, right? Because if you recall the first method, I told you this is how it should be done. That's how we did it here. So if you do this, it's correct, but it's unnecessarily. The easiest way, which you can do it in your mind, basically without using a calculator really, is to find a common denominator. The common, I think it was 32, yeah. So what is the common denominator of 12 and 32? 12 can be rewritten as 2 to the power of 2 times 3. So by now you should have mastered this method. If not, I suggest you to go back and take a look at the first video about HCF and LCM, right? HCF and LCM. So 32 can also be rewritten as the product of prime numbers, which in this case give us 2 to the power of 5. And we go for common and uncommon, right? Factors with the largest powers. In this case, it's this times this, right? And the answer is basically 32 times 3, which give us 96. And then you can say 96 divided by 12 times this. So 96 divided by 12, well, basically 96 was, if you want to do it mentally, 96 was 2 to the power of 5 times 3, right? And if you divide this by this guy right here, the only thing is left is 2 to the power of 3, which is 8. 8 times 5 is 40, plus 96 divided by 32, that gives us 3 times 15, that would be 45, and the final answer is 85 over 96. Now, I could have done that faster. The good thing about this method is that if you practice more and more, you get faster and at it, and you don't really need to use a calculator at all. Guys, I know this one right from the beginning, we could have used a calculator, but as an IGCSE student, as I told you many times before, a calculator slows you down. And after all, some of these questions, they ask you not to use a calculator. So you should know how it works. So we did a subtraction here. Maybe we do a couple of mixed fraction and see how it works if we have a mixed fraction. So for the mixed fraction, you need to convert it to an improper first and then perform the addition or subtraction. So in this case, this is a subtraction, and we have 1 and 3 over 8. So subtract the whole number separately and the fraction part separately as well. And this is basically 4, and you find a common denominator for 5 and 8, which is basically 40. 40 divided by 5 is 8 times 3 24 minus 40 divided by 8, 5 times 3, 15. And the final answer is 4 and 9 over 4. About multiplications and division, that is quite easy. Multiplication and division. It's easy because it's quite straightforward. You just have to multiply the numerators separately together and do the same thing for denominator. So if we have 1 over 3 times 2 over 5, the answer would be 2 times 1, 2, 3 times 5, 15. And if they're asking for the simplest form, we might have to cancel some factors out. For example, 4 over 15 times 9 over 12. Now, in this case, before you perform the multiplication, you can factor some numbers out, right? For example, 12 and 4, you can divide both by 4. This gives you 1. This gives you 3. And then 9 over 3 is basically 3. So 9 is gone. We're left with 3. 3 divided by 3, 1. And again, 3 over 15 itself can be simplified as 1 over 5 because 15 is 5 times 3. So this, you don't have to necessarily multiply 4 by 9 and 15 by 12. So this is an easier way. Always look for common factors. Let's do another one. Okay, so you're asked to find the answer for 3 over 8 times 4 over 5. And guys, please take a note that so far I haven't used a calculator at all, right? So I hope that you guys do the same thing. At least if you do this, if you use a calculator at first, it's all right, but work towards not using a calculator at all. So this is what they ask us. This is the expression given to us, and we've been asked to evaluate it. So for the first one, before I perform any multiplication, I'm gonna cancel this 4 from the top, and 8 divided by 4 is 2. So here the answer would be nothing but 3 over 10 plus. So here, if you have two fractions and the word off between them, so treat that as times. So when they say what is half of 10, so half of 10, basically it's half times 10, right? Or what is 1/3 of 5? So it basically 1/3 of 5 is basically 5 over 3, right? So that's the idea. You multiply that. So same thing here. We have 3 over 10, and well, we're lucky that the denominators are same, so we just add the numerators, which gives us 6, and we can simplify that. So it's a good habit that you try to simplify the fraction even if you're not told to. So, and everything can be divided by 2, which leads to 3 over 5, right? And about the division, so for the division, you can convert it to multiplication and then perform the division. What do I mean by that? Before I tell you the technique, let me introduce you to a term called reciprocal. So what is a reciprocal? Whenever you divide 1 by a number, you're finding the reciprocal of that number. So if you're asked to find the reciprocal of 5, so it's basically 1 over 5, or the reciprocal of 3 is 1 over 3. Now, if you're having a division, if you're dividing two fractions by each other, so this would be 2/3. What you need to do, you can convert this division to multiplication by converting the second fraction to its reciprocal. And if the reciprocal of 5 is 1/5, the reciprocal of 2/3 is 3/2. You just have to switch the numerator and denominator, right? So basically, I convert this division to multiplication by just changing the second fraction, not the first one, to its reciprocal. And if I do that, you see that this 3 and 12, there's a common factor, and that's 3. They cancel out, and the final answer would be 5 times 1 and 4 times 2, 5/8, right? That would be a faster way to do. So whenever you see a division, it's easier to convert it to a fraction. So let's do one more. How about maybe you can try this yourself. 9/16 divided by we have here 12, and here we have 15. So this is an improper fraction, as you can see, because the numerator is larger than denominator. So don't start simplifying here, because that would be wrong. You cannot cancel 9, anything from 9 with anything from 12. That would be wrong. Convert it to multiplication, then start the simplifying. So 12/15, this is 9/16. Then I can say we have a 1, 3 here is gone. 3 from 15, you left with 5. 2 or 4. Yeah, 4 is the HCF of 12 and 16. Basically, the largest number that both can be divided into. And 12 divided by 4, you left with 3. 16 divided by 4, you left by 4. And the final answer would be 9/20. And I believe you cannot simplify this further, and that's the final answer. So remember the term reciprocal and its use when it's come to dividing two fractions together. So the last thing is converting. You have already learned how to convert decimals to fraction and fractions to decimals, right? However, we have a special type of decimals. It's called recurring decimals. Do you remember the rational numbers? We had integers. We had integers. That would be the letter Z representing integers. We had then terminating decimals such as 0.2 or 0.95. So terminating means it ends somewhere, right? And we have recurring decimals. Recurring decimals, it means it keeps repeating. So basically the recurring term here is 3. So I have to show it with 3 dots. There are 2 ways you can actually show this. Either I write it this way, so it means 3 keeps repeating, or the easiest way and the professional way, which you also have to do that, follow that from now on, is to put a dot on top of 3. So basically it means the 3 keeps repeating, right? And so on. So what if we have 2 digits keep repeating, like 0.25, 25, 25, and so on. So the idea is that you put a dot on top of 2 and 5, and if you have non-recurring digits such as 2 and 3, such as this example, 2 and 3, and then suddenly we have a 6 which keeps repeating. So as you can see, 2 and 3 is non-recurring, however 6 keeps repeating. If you want to show this in short format, we have 0.2 and 3, we leave it untouched, and for 6 we just put a dot on top of 6, right? As simple as that. And just the last example, it was to take a look at it. If we have more than 3 digits that keeps repeating, such as 2, 3, 4, 5, 2, 3, 4, 5. So you see the cycle, it's the 2, 3, 4, 5 that keeps repeating. So if you want to write this in short, you don't have to put a dot on top of each decimal. So what you can do is just put a dot on the first digit and the last digit that keeps repeating. So if you put a dot on top of all of them, it's right, it's correct, no issue. But if you see something like this, you should know what it means. Okay, it doesn't mean 2 keeps repeating until when, right? And then you have 3 and 4, and then 5 keeps. That doesn't really make sense. So don't treat it like that. If there is a dot on top of the first and last digit, you should know what it means by now. It means this whole thing keeps repeating. Now, now that you know how recurring decimals look like, so you should know how to convert it to a fraction form. So if I ask you what is the decimal format of 2 over 10, I'm sure you all know it's 0.2. How about 2 over 9? If you key in your calculator, you get 0.2 with the repetition of 2, which in short, we show it like this. We put a dot on top of 2. But is there any way that you can calculate this yourself without using a calculator? Well, yes, there is. And there is actually a question each year, but this part is for extended. Those students who are interested to take the extended papers. For core students, you don't need to learn this topic. Now, it's very straightforward. I mean, the method is easy to learn. So let's take a look at the one that I just told you, 0.2 with the repetition of 2. So how can you rewrite this as a fraction? And you know what a fraction means. A and B should be integers, right? So that's the idea. So I want to write it in this format where A and B must be integers. So what are A and B's? What are the values? So what you need to do first, you call 0.2, our recurring decimal, you call it X. You can use any letter, but it's more common in math. We use the letter X. So 0.2, and what you can do, perhaps I just show it in these formats first, because now I'm gonna multiply it. So in the second row, you have to multiply both sides by a multiple of 10. But is it 10? Is it 100? Is it 1000? What is that? Well, you have to take a look at the digits that keeps repeating. How many digits we have that keeps repeating? We have only one digit. So if that's the case, you multiply both sides by 10, which gives us 10x for the left-hand side. And the right-hand side, we have 2, right? When you multiply a decimal by 10, you move this decimal point 1 unit or 1 position to the right, and you get 2.222 with the repetition of 2, right? So I purposely expanded this recurring decimal and showed it in this way so you can see what happens. We still have infinitely many 2 left, right? And then what you need to do, you subtract the first row from the second row. And in order to do that, maybe you need to rewrite them. Maybe it's better I write 10x on top. So when I do the subtraction, the digits are eliminated easier. So this is what we have at the bottom. So everything after decimal point is gone when you subtract them together, right? Because after decimal point, we have nothing but 2. And here we have 2 minus 0, that is 2. And 10x minus x is 9x. And if you make x the subject of the equation, you divide both sides by 9. That gives you 2 over 9. And that is the final answer because x is nothing but 0.2. That's what we called x, right? So x is the number that we work on. Therefore, 0.2 with the repetition of 2, that's a recurring term, would be equal to 2 over 9, right? So that was an easy example. But what if we have 2 digits that keeps repeating, such as 0.34, and the repetition is basically the number 34. So we have, if I want to expand this, I have 0.34, 34, 34, and so on. So I'm going to call this, that's the first step, call it x. So if you want to expand it, just to see the patterns, you can do that. And then maybe, now the question is what multiple of 10 I should choose here. Is it 10, just like the previous example, or it should be 100? Well, you have to take a look at the digits that keeps repeating. I have 2 digits here. So I should multiply by 100 this time. 100x is equal to, if I multiply the right-hand side by 100, the decimal point moves to right by 2 positions. So the final answer would be 34 with the repetition of 34, right? So you could always, if you could do this step in your mind, it's not wrong if you write it this way. So 100x is equal to 34 point with the repetition of 34. You can do that as well. It's the same thing, these 2 steps, but I just expanded it so you would see easily what happens next. Now you have to subtract x from 100x, so it's better if you write 100x on top. So, all right, and minus x, which is basically 0 point. So when you want to subtract, make sure the decimal points are aligned, right? Don't put the decimal point here or here. This makes it way easier for you. And then I have 34, right? Keeps going. So everything after decimal point is the same for both decimals. So when I perform the subtraction, basically everything is gone. However, 34 minus 0 is 34. 100x minus x is 99x, and the final answer is 34 over 99. And I believe I cannot simplify this further, and this is the final answer, meaning which 0.34 with the repetition of 34 is equal to 34 over 99, right? But let's take a look at another interesting example where we have a bunch of numbers, the basically non-recurring digits as well as recurring digits, like this scenario, 0, 1, 2. So 1 and 2 keeps repeating, but not 0. So basically, if you want to expand this, this is what you get, 0.0, and then 12, 12, 12, 12, right? So 0 is non-recurring digits here. Now, how do I treat this? Still, you have to call this x, right? So x is 0.0112. So, or if you want to write the other version, it's okay. So with 3 dots, so I raise these 2 dots. Now, the question is, should I multiply by how many recurring digits we have? We have 2. And just like the previous example, if I want to follow that procedure, I must multiply this by 100, right? So there are 2 ways you can do this at this point. In some books, they multiply by 1000, and in some books, they multiply just by 100. At the end, both will get you to the same answer. It's just the final step would be different, right? There is one extra step at the end, which I'm going to show you in a minute. What do I mean by that? So let's say right now we know the recurring digits are 2. So I just multiplied by 100 then. And if I do that, this decimal point moves 2 positions to the right, and we left with 1.2121212, right? Because the 0 before 1 is it's actually, it doesn't have a value, right? So we can neglect that. And then same procedure, the 100x goes on top because you want to subtract it. So x should be subtracted from that. So if I do it, we have 1, 2, 1, 2. So it keeps repeating. As you can see, 2 is not repeated. And then x is 0 points. So I told you make sure the decimal points are aligned from top and bottom. So this is 0, 12, 12, and it keeps going. Right? This step is very important, guys, for you to make sure the decimal points are aligned. Then the answer kind of reveals itself to us, because at this point you can see that the 12s right after this position, everything is gone from top and bottom, right? Because 12 keeps repeating itself. However, 2, after the decimal point, 2 minus 0 is 2, and 1 minus 0 is 1, and 100x minus x is 99x, and we're left with basically 1/2/99. This is not a fraction. Why? Because the numerator is not an integer. 1.2 is not an integer, right? So how can we take care of that? Well, it's very easy. All you have to do is to multiply top and bottom by 10 to push this decimal point 1 unit further, 1 position further, and you get 12/990. And then this is the answer. So this is the extra step that I told you. You have to do it at the end. And this is the difference with previous examples. So I'm just going to do one more, and then we can stop. How about 0 point? So let me open a new slide. So 0.0009, and the repetition is on 9. Actually, 9 is the repeating term. So if you want to expand this, basically, this is what you see. 3 zeros and then 9, 9, 9, 9, and it keeps going forever. So let's call that x. This is the first step, and you should always do that. You can write the expanded version of it or stick to this one. Both is correct. Now I have to multiply both by 10 because the digit that keeps repeating is only one digit. So that's 10x. And if you multiply this by 10, so maybe I can show you with another color. So if you multiply it by 10, the decimal point is pushed one position to the right. So the final answer is basically 0.009. So instead of 3 zeros and then 9, we have 2 zeros and then 9. And then you can write 10x above. Again, guys, there is another way to do this. I could have multiplied by 10,000 as well, as I told you earlier. And there is another way. In some books, they show it that way, but at the end, it doesn't matter. It doesn't matter because we get the same answer. So let me write 10x here, 009. So I expand this just so you see what's going to happen now. And 0.00, so we have the decimal point. I'm going to make sure they are aligned. We have 3 zeros and then 9 is recurring there. So if I subtract them, 9 after the second 9, not the first one. After the second 9, everything is gone when you subtract that, right? However, 9 minus 0 is 9. 0 minus 0 is 0. 0 minus 0 is 0. This is our decimal point, and this is the 0 before the decimal point. And then 10x minus x is 9x. And now all I have to do is divide both sides by 9, which gives me 0.009 divided by 9. Now I have to multiply because this is not an integer, right? This is not an integer. So what I need to do is to multiply top and bottom by how many zeros I should put in front of 1, 3, right? So basically 1,000, because I want to push this decimal point all the way here. 3 position, I have to move it to the right. Therefore, I multiply it by 1,000. Here I get 9. And in the denominator, I get 9,000. I can simplify this further, and you should do that as well. The 9 and 9 is gone, which is equal to 1 over 1,000. And having said that, I think this is a good place to stop. I'll see you guys in the future video.